Okay, so let's say we have two functions. Function 1, I don't know, let's just straight lines. Straight lines are easy. And this function here. And they're not parallel, let's give them names. So this one can be y equals x plus 1. And this one can be y equals, let's go 2x. So it would probably, it would look something like that. So we've got these two functions. Now I want to know the area. I'm going to make this 1.2x because otherwise it might not work very well. So I want to know the area between these two curves from 0 to let's say 1. Okay, so these are not parallel. I've sort of drawn it a little bit so that it looks that way, but it's not actually parallel. And I want to know what area is between those two lines. So how can I do that? Find the difference between the two areas. Okay, so if I look at these two integrals, so if I found if I draw the x plus 1 over here, so this is x plus 1, looks something like this from 0 to 1. Okay, that would be, let's call that A1. And this area under here, this is x plus 1. This area under here, we'll just dot it in so it doesn't get confusing. We'll call that A2. So we can see that our total area, a shaded area, is going to be A1 take away A2. That's a fairly straightforward concept, isn't it? Okay, yeah. Okay, let's move on. So let's look at A1 first of all. So A1, what are our bounds for our integral? 0 to 1 of x plus 1 dx, which is going to be our integral of x plus 1 is x squared on 2 plus x from 0 to 1, which is 1 squared on 2 plus 1 minus 0 squared on 2 plus 0. So that's 0, so we end up with 1.5. So area 1 is 1.5. Area 2 is the integral from 0 to 1 of 1.2x which is integral of 1.2 is 0.6x squared. Increase the index by 1, divide by 2 from 0 to 1, which is 0.6 by 1 squared take 0.6 by 0, so that's 0, so we have 0.6. So our total area is going to be 1.5 from here. Area of 1.5 minus 0.6. Okay, which is 0.9. So our area between those two curves across those bounds is 0.9. Now, that's all well and good. We've had to do two integrals there, and we've really had to do two areas. Now, I would like to do this in one go. Okay, now we have a particular law for integrals, which I've mentioned before, right when we started our integration last term, but we never actually really used it that much, and it's this law here. If we have some integral, and we add or subtract a different integral, that's an integral sign, then that's the same as integrating once for those two integrals combined as one function. Okay? So, what this means for us is, what could we have done here instead of integrating the two areas separately? Sorry? Combine the equation. So we could say, because we have our two integrals, so we have x plus 1 and we have 1.2x. Okay? If we combine these two by subtracting them, we will end up with one function which we can integrate. So let's have a go at that. Sorry for those people that were still copying down. You know what, I can do it down here. So let's go, our total area could actually be the integral. Now our function is x plus 1 minus 1.2x dx, which is x take 1.2x is negative 0.2x plus 1 dx. Okay, so if we integrate this from 0 to 1, we get negative 0.1x squared plus x from 0 to 1, which is negative 0.1 times 1 squared plus 1 minus 0 plus 0, it ends up being. So that's nothing. So that's negative 0.1 plus 1 is what? 0.9. So we get the same area that we were expecting. Whenever you have a combination of two integrals and you're wanting to find the area between them, you can simply combine those into one function first, and then you have one integral. And although some of the places you might read this, the textbook, they might do two separate integrals. You know, I think this actually simplifies it a lot. So I'm going to stop this recording. We'll do another example in a moment.